All right, so here's assignment 1-4. Question number 1 is to find the derivative. That's kind of blurry. Let's see if I can focus it in. There we go. How do you find the derivative using limits? I'm going to tell you the next lesson is shortcuts, and then we're just doing shortcuts. So it's good practice for you. So the derivative is this. The limit as h approaches 0. What do you do first? X plus h. So plug in x plus h, subtract the function. Use always parentheses for when you subtract the function so you don't make a mistake, and that's all over h. And now we do some algebra. So that's negative 3x, and a negative times the negative is positive 3x. So they cross out, and so all you're left with is negative 3h over h. Divide out the discontinuity, and now all you're left with is negative 3. There's nothing to even plug in, and there's your answer. Number 2, I want to find the derivative of this using the limit. So step 1, the limit as h approaches 0. We're going to evaluate first at x plus h, subtract, and then use parentheses when you just plug in the function without x plus h. And that's all over h. Now we're going to expand. I'll do this in 2 steps. X plus h squared. You can draw a box and FOIL or know the pattern, however you want to see it. And then be careful, it's negative x squared plus 1. Notice x squared crosses out negative 1 and positive 1. And then what's left over we're going to factor and then divide out the discontinuities. We're going to factor out an h. We're going to cross out the discontinuity and then plug in 0 for h, and the answer is 2x. And you already knew that, right, if you knew the shortcuts. Number 3, this one's going to be a little more challenging because it's a fraction. So the derivative of it, I'm just going to get right into it. The derivative of it as h approaches 0. Step 1 is to evaluate at x plus h. And then step 2 is to subtract. Again, I like using parentheses. In this case, it's not necessary, but it's good practice to be in a good habit. We need to write this as one fraction. So I'm going to multiply by x subtract 1, top and bottom. So we have x plus h, subtract 1, x minus 1. The second fraction, I'm going to multiply by this denominator. So when I multiply it times 1, it's x plus h minus 1. And then we have common denominators that way, so we can write it as one fraction. So now we're going to write it as one fraction. I said this is a little more challenging because it's a fraction. So common denominators, x subtract x, they're eliminated. Negative 1 subtract negative 1, that's eliminated. So the only thing left is negative h. I'm actually going to do it like this. So negative h, we have x minus 1, x plus h minus 1. Instead of dividing by h, we're going to right away multiply times the reciprocal. H divides out, and you have negative 1. Plug in 0 for h, so you have x minus 1, and then you have x minus 1. So we could write that as x minus 1 squared, and it's done. Number 4. I hope these are getting better. I know it's a little tedious, especially if you know the shortcut. This one's not going to be fun because you know the shortcut. So we're still going to do the work, but I'll help you through it. So we first, it's t, so we're going to go t plus h cubed, t plus h, and then t cubed minus 12t. So there's the setup. Do you want to distribute t plus h cubed? There's a pattern to that. It's the binomial theorem. I'm going to just do it for you. So the pattern is t cubed plus 2t squared h plus 2th squared. Is it 2 or 3? 1, 3. It's 3, right? It's 3. 3. Do I know the pattern? And then h cubed. It's going to be long. We have minus 12t minus 12h minus t cubed plus 12t. Now it's going to get better. So now we combine like terms. So t cubed, they cross out. What else crosses out? Negative 12t and positive 12t. And then we're going to factor out an h. So we have an h, that's 3t squared. We have an h, that's 3th. We have an h cubed, so it's h squared. and then negative 12. Divide out the h, and now plug in 0 for h, so all that's left over is 3t squared minus 12. And if you know the shortcut, you know that's the answer. Number 5. Last one like this. So what would the setup be here? We know the answer. This is what the setup would look like. So first of all, you plug x plus h. There's nothing to plug in, so it's just 3. Subtract the function, which is 3 all over h. So 3 take away 3 is 0 divided by, anyway, the answer is 0. And you knew it. So 6. I'll use the alternate form here to find the derivative at a point. So I want to find the derivative at 2. So the limit as x approaches 2. Just the function, which is x squared minus 1, and then subtract and plug 2 into the function. So that's 4 take away 1, which is 3. And then the denominator is x minus 2, using this value. And now a little bit of algebra. This is x squared take away 4. That's the difference of squares. That's x plus 2, x minus 2. Now the discontinuity divides out. And now plug in 2 for x and you have your answer. Number 7. I want to know the derivative at 2. Let's see how fun this will be. We have x cubed. Oops, I need limit notation. The limit as x approaches 2. And then we have this. So the function's x cubed. Subtract 2x squared. Subtract 1. Subtract. Then you plug 2 in for x. That's 8. Take away 8. That's 0. So all you're left with is negative 1. And that's all over x minus 2. It's actually going to simplify to something a lot nicer than I thought. So negative 1 take away negative 1. This is what you're left with. So we factor out an x squared. So you're left with this. When you factor out, so the negative 1's cross out, factor out an x squared. So x subtract 2 divides out, plug in 2. And 2 squared is 4, and you have your answer. I thought it was going to get a little uglier. Number 8. In number 8, to find the derivative at 3. So to find the derivative at 3, the limit as x approaches 3, the denominator is going to be x subtract 3. The numerator is going to be the function. Subtract, plug in 3 for x, and that's 1/3. To simplify this, we need common denominators. So we're going to multiply by 3, top and bottom, and by x, top and bottom. So I have 3 minus x over 3x. And then we do the, instead of dividing times the reciprocal, I want you to notice that these are opposite factors. That leaves you with negative 1. So when you plug 3 in for x, you get negative 1/9. Number 9. We have the function x minus 1 to the 2/3. I don't know, I just wrote it for fun. The derivative at 1 is the limit as x approaches 1. The denominator is x minus 1. We are going to start with the function, which is x minus 1 to the 2/3 minus, plug 1 in, and you get 0. So we're actually going to use exponent rules to simplify this. So notice they have the same base now, so we subtract the exponent, so you end up with the limit as x approaches 1. When you subtract, oops, I don't need a fraction anymore. When you subtract, it's negative 1/3, so no fraction and such, and then you plug 1 in, and then what you'll find, I think it's undefined, right? It doesn't exist. So the derivative doesn't exist. So this is like this. So negative 1/3 is like this. And then when you plug 1 in, it's not indeterminate, it's undefined. So this limit doesn't exist. That derivative doesn't exist at that point. Number 10. Use the limit definition to find the derivative. So we just did that, right? So the limit definition is the limit as h approaches 0. We start with x plus h and then we subtract the function. So it takes a moment to make sure you use parentheses and do a substitution correctly. Subtract the function at the end. Now we need to do some algebra. We need to expand FOIL. That's x squared plus 2xh plus h squared minus x minus h minus x squared plus x. And now combine like terms. So we have x squared minus x squared, negative x plus x. Then factor out an h, and you have 2x plus h minus 1. Divide out the h. When you plug in 0 for h, all you're left with is 2x minus 1. And if you know the shortcut, it is 2x minus 1. Number 11. Use the limit definition to find the derivative here. So it's going to be the limit as h approaches 0. First I plug in x plus h. Then I subtract the function. So there's the setup. I'll help you with the pattern to expand that binomial. It's going to be x cubed plus 3x squared h plus 3x h squared plus h cubed plus 1 minus x cubed minus 1. Now I want you to notice the x cubes, subtract out, 1 subtract out. We're going to factor out the h. The more we do this, right, it's not so bad. We have 3x squared plus 3xh plus h squared. Divide out the h, plug in 0, and all you're left with is 3x squared. And you knew that answer at the beginning, so it's good to know that you can do it both ways. Number 12, practicing the limit definition. So the derivative of this, again, isn't it the more we practice, the better we get, right? We see the patterns. So plug in x plus h for x. Use subtract, use parentheses, and then just the function without h. We're going to do some algebra to expand it. So that would be x squared plus 2xh plus h squared. That's the pattern. And then we're going to eliminate and factor. So 2 times x squared and negative 2x squared, they eliminate. 2 times 2 is 4xh. 2 times h squared is 2x squared. And 4 and 4 eliminate. So all we're left with now, we're going to factor out an h. Plug in 0, and you get the answer 4x, which you knew. And then the derivative at what value? 4 would then be 4 times 4, which is 16. Number 13, we're going to use the alternate thing and do the exact same thing, but using the other way for number 13 to find the derivative at a point. So if I want to directly find the derivative at 4, it's the limit as x approaches 4, and it's x minus 4. And then in the numerator, we have the function, subtract, and then we plug 4 into the function. That's 32 plus 4, which is 36. And that's what we find the limit of to get the derivative. So we have, what do we have here? We have 2x squared minus 32. Factor out 2. That's a difference of squares. So that's x plus 4, x minus 4. Now we can remove the discontinuity. Plug 4 in for x, and you know the answer. It's going to be 16. All right, some trig. 14. Let's do it. I like some trig. Secant squared. It's like knowing a secret language. So in this case, we're going to solve this. We're going to add 4 when we square root. The answer is positive or negative. And now I think it's easier to understand it's cosine, right? So it's the reciprocal. And then think, okay, cosine is the x value. It's both positive and negative, so it's all 4 quadrants. But what's the reference angle here? And the answer is 60. So it's all of them, because it's positive and negative. So it's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Number 15. In number 15, sine squared is equal to cosine squared. So the question is, where are they equal to each other, both positive and negative? And the answer is at 45-degree angles, right? So it's at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So when are they equal to each other? At this one, right? Whether it's, the reason it's being squared is it could be positive or negative being equal to each other, and it's a 45-degree where they're equal to each other, and those are the angles. Number 16, tangent theta subtract sine theta is equal to 0. Tangent is sine over cosine. Factor out a sine from each one. Oh, there it is. Factor out a sine from each one. And then make each one equal to 0. So when is sine theta 0? So that's positive or negative 1. So that's on the left and on the right of the unit circle. So those angles are 0 and pi. For the second one, 1 over cosine is the same as secant. They're actually equal to the same, because 1 over cosine theta equaling subtract 1, add 1 to the other side. When you do the reciprocal, it still stays 1 on both sides. So when is the x value 1? And the answer is at 0. We already have that, so the only two angles are 0 and pi. Number 17. All right, to solve this one, we need to know a Pythagorean identity. So sine squared plus cosine squared is equal to 1. So therefore sine squared is equal to 1 minus cosine squared. And I can do a substitution. So 1 minus cosine squared. So I can do a substitution. Now we only have cosine. Distribute. Now it's a quadratic. So I'm going to add 2 cosine squared to the right. We already have positive cosine theta there. And then I'm going to subtract 2. So 1 subtract 2 is negative 1. If you like, you can do a substitution to make it look easier. So instead of cosine, make it x. So it's just a regular quadratic to look at. So two numbers that multiply to negative 2 and add to 1. Because these are prime, there's really only one combination that's going to work here. So 2x times x, that's the only thing that will make 2x squared. 1 times 1 is the only one that will make 1. We just need the signs correct so they match. So negative x and positive 2 make the positive, so it's there. Then, when we make each equal to 0, then you can put cosine back in when you make it equal to 0. So we're going to add 1 and divide by 2. Where is the x coordinate? 1/2. So that is a 60-degree reference angle. So that is over 3. What quadrant is cosine positive in? So cosine goes with x. So it's positive here and it's positive here. So that would be 1 pi over 3 and that would be 5 pi over 3 here in quadrant number 4. The second one, instead of x plus 1, we're going to write cosine plus 1. So when I solve it, subtract 1. When is the x value negative 1? Negative 1, 0 goes with pi on the unit circle. That's directly to the left. And you have your 3 angles that fit. Yay! No more trig right now. One day you'll know the secret language. Number 18, use a calculator. So if I want to use a calculator to solve this equation, let me do that for you with you. See if I remember. I need to remember how to put a domain restriction in. So the first part's easy. Menu algebra, we're going to solve it. So then we're going to type it in. So that part is simple. Now let's see if I do it right the first time. So this is tangent x. Move the cursor. equals cosecant squared. So I'm going to do this. So cosecant squared, am I typing it right? Subtract 2. Now, I want to solve for x, so I'm going to do comma x. And now on the outside, I'm going to put a restriction in. So I'm going to go control equals, I'm going to use this. And now I'm going to put in the restriction. And the restriction says from 0 to 2 pi. So I'm going to go 0. 0 is blocked. So it's going to be, oops, less, greater than, this one right here, x. And then the other one's just less than 2 pi, right? So that's one way to put it. Let's hope, right? You think I did it right? So I put it in with a restriction. So it's 0.646. And you have the answer. All right. Number 19. In number 19, use the graph on the right. See if I can show both at the same time. Make it simpler on myself. So there's the graph. Let me just explain first. So the absolute value bars, only the part that's below gets reflected up. So everything else is going to stay the same and just regraph it. So I'm going to do that right now. So that part that was below just gets reflected up. For number 20, what's the graphing adjustment there? It's everything's been shifted to the right 2 and up 1. So I'm going to take every point and shift it to the, it's going to go 1, 2, 3, 4. It's going to go all the way to 4. And then up 1. So it's going to go up to 2 now. All right. So if I shift it to the right, this is where I'm going to start. Oops. I'm going to start and up 1. So right here is where I'm going to start. Then here, then here. So it's been shifted to the right 2 and up 1. So there's this part. And then the last one would be right here. And you have it. So this has been shifted to the right 2 and up 1. And that's what it looks like. 21. One more like this. What does the negative and the 2 do? So the negative is a reflection. So the first one's going to be at, and then it goes times 2. So you reflect and then a vertical stretch. So I'm going to reflect and then it stretches down here. This doesn't reflect or stretch, so it stays here. The next point's going to reflect and stretch here. So this is what it's going to look like when you reflect and stretch it. And then the last part at 2, we're going to reflect it and then stretch it up to 2, and then you have it. So that's what it looks like. 22, you have a function and you're told to do everything. So let's do it. So the domain here, x cannot equal positive or negative 1. If I factor this, it'd be x plus 1, x minus 1. So what gets removed creates a whole. So the 0 of what got removed is positive 1. And then what's left is 1 over 1 plus 1, which is a half. So there's the whole. The vertical asymptote is what's non-removable. So negative 1, and it's odd. The x-intercept is 0. Again, it's odd, because it has an odd exponent. And that will also be the y-intercept too. So let's put this together and see what the graph looks like. So we have, what's a good place to start? So the vertical asymptote's at -1. Oh, I didn't do the end behavior. Let me do that too. Do you notice for the end behavior, x and x are the power terms, so when they divide, the end behavior is just 1. Oops. There's also a whole. Where's it again? At 1 and 1/2. And there's an intercept here at 0. And then draw your picture. All right. On to 23. All right, these are quick questions looking off a graph, so I'm going to write them down and then quickly answer them. So the limit as x approaches -1 of f at x. The limit, the function value at -1. The limit as x approaches 1 of f at x. I'm just writing them all down. And then I'll come back and answer them. The limit of x to the right. These you should be able to answer without me. I'm still going to write these down. These are really good conceptual questions, not difficult questions, to know that you're on the right track. All right, here we go. I'm now ready. So, let's start at the beginning here. So, what's the limit as x approaches -1? So find -1. Here it is. The limit is the y value there, which is +1. I'll say it out loud, and at the end I'll show you my work. The next one, what's the function value at -1? So at -1, the close point is at 0. What's the limit as x approaches 1? So from the left and from the right, there's a jump. So that limit does not exist. How about 1 from the right? The y value from the right is 3. What's the limit value at -3? Find -3. It's continuous there. It's just the y value, which is +1. What's the limit as x approaches infinity? That's the right end behavior, so the right end is going to +1. 29, what's the limit as x approaches -infinity? The left end behavior is approaching 0. What's the limit as x approaches -2? So a limit doesn't exist at an asymptote, or you could say that the answer, because both ends are going to infinity, the other answer you could say is infinity. Where are the removable discontinuities? So that's a discontinuity where the limit exists. So at -1 is a discontinuity, the limit exists, and that's it. That's the only one. And then the non-removable discontinuities is where the limit does not exist. So the asymptote. So -2 is a non-removable, and at +1 there's a jump. The limit doesn't exist. So those are the two. So at -2 and +1. Let me show you. So those are the answers there from 23 to 30. And then those are the answers in terms of removable and non-removable. All right. I know you can press pause if you had to. 33 and on. Find the following limits without using a calculator. All right, let's go. The limit as x approaches 2 of 5x subtract 3. Step 1 is just to evaluate. And if you get an answer, it's done. So plug 2 in and you get the answer 7. If you substitute in and it's indeterminate, then we're going to use algebra. For this one, I'm going to factor right away because it is indeterminate. When you plug in 3, you get 0 over 0. So we're going to eliminate this and be left with -1. Plug 3 in, and the answer is going to be -6. 35 Again, we're using t. Gotta be careful there. We're going to factor. So that's going to be t plus 3 and t subtract 3. These eliminate. If you plug in negative 3, you get negative 1/6. For 36, again, when I plug in 2, it's indeterminate, so I'm going to factor. Even if I didn't know it, it's easier to factor and then evaluate than it is sometimes just to plug in. So that's negative 2 and negative 1. So you can see it's indeterminate. Remove it. When you plug 2 in now, it's 4 over 1, or the answer is 4. For 37, it's a one-sided limit from the right. So 0 gives you asymptote. If I plug in a positive number there, you can see that it's going to infinity on the right and going to negative infinity on the left, so it's infinity. If you plugged in a number bigger than 0 and it was a negative answer, then it would have went to negative infinity. We go 4 left, 38. Again, my goal is really to work hard to make sure that it's under an hour, right, in terms of this assignment. You have to practice, or you're not going to get better. That's part of the deal. But I don't want it to be overwhelming. If you plug in 1/2, it's indeterminate, so we're going to factor. If I factor out a 4. If I factor out a 2, you get 2x minus 1. Jeez Louise. Divide out 2x minus 1. There's nothing left, so the answer is just 2. 39. It's indeterminate. Don't assume it, but you should be able to plug in and see it. When I factor the first time, it'll be x squared plus 1, x squared minus 1. Factor it again, and it's going to be x plus 1, x minus 1. So x squared plus 1 is prime, but this one can be factored again. This is removed. Plug 1 in, and you get 2 and another 2. 2 times 2 is 4, so it's a quarter. 40. So again, don't assume. This is not indeterminate, just so you know. So if I plug 1 in, the denominator is 2. Plug 1 in on top at 0, so 0 divided by 2, so the answer is 0. Good to not assume. 41. 2 left. We're almost there. You can do it. This one is different because we're using x subtract 1 on the bottom. So I'm going to factor the top, which is x subtract 1, x subtract 1. This is now removable. Plug in 1 and you get the answer 0. 42. And we're there. Oh my trig. Oh my trig. Here we go. So, limit as x approaches 2. How fun is this? So it's not indeterminate because if I plug 2 into the top, it's not 0. So it's either going to be undefined or what it is. So let me just focus on the denominator. So if you plug in 2, you get 2 over 4, or 1/2. Tangent at pi over 2 up here is y over x, which is undefined. So this answer is undefined, while this answer is a number. So altogether, that limit is... Oh, they changed the limit. Well, let's do that. So instead of tangent on the bottom, the reciprocal of tangent, because then you can evaluate it. I didn't know. I looked at the answer too quick. The reciprocal of tangent is cotangent. So I can write it this way. And then, if you plug in, we're now looking at cotangent pi over 2. Well, cotangent pi over 2, that's x over y. That's 0. So 0 times anything, this answer is 0, and it's over. Mr. G Math over and out. I am so proud of you for doing your work and fighting through this and being positive. Until next time.